Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 7th lecture of grade first year. The chapter name is Thermochemistry and the topic name is Standard State and Standard Enthalpy Changes. Standard enthalpy changes. This is the relationship between the internal energy of a system, means del U or del E, and thermal energy at constant temperature and pressure. First law of thermodynamics can be applied to processes carried out under different conditions. Either we constant the volume or either we constant the pressure in case of P del V. In the previous lecture, I have derived equation P del V, that is equation of work is P del V. So we can measure the standard enthalpy changes either by keeping volume constant or pressure constant. There are two main conditions under which the processes can occur, that is at constant volume and at constant pressure, which is the most common way of carrying out chemical reactions. When we constant the pressure and heat is supplied, it will expand and work will be done on the surrounding against external pressure. The opposite will be in the case of constant volume. So, it has also been shown that processes at constant volume follows the equation del E is equal to QV. What is enthalpy? According to the first law of thermodynamics, del E is equal to QP plus P del V, where QP is the heat transferred to the system from the surrounding. P del V is the work done by the surrounding on system at constant pressure, which we have calculated previously. P del V is the work done by the surrounding on system at constant pressure. So we can rearrange this equation as QP is equal to del E plus P del V. P del V is the pressure volume work, that is constant. At constant pressure the gas will expand and the work is done on the surrounding, and at constant volume work is done by the surrounding. In the second case, if system is doing work on the surrounding, it means now the work will be negative. In case the work will be negative, then del E will be equal to QP minus P del V. I am taking it as negative because system is doing work. Now adding P del V on both sides and we will get the value of QP, that is del E plus P del V, where QP is the heat absorbed or evolved by the reaction at constant pressure is also known as enthalpy of the reaction. Heat absorbed or heat evolved at constant pressure is also known as enthalpy of reaction, that is del H. It means that change in enthalpy, that is del H, is equal to QP, which is equal to del E plus P del V. So thermal energy for a reaction is equal to the change in internal energy of the system plus pressure volume work done by the system at constant pressure. At the start of the lecture, I have told you that this tell you the standard enthalpy changes, tell you the relationship of thermal energy for a reaction is equal to change in the internal energy at constant pressure. This thermal energy is also called as enthalpy change of the reaction. So from the above equation we derive that enthalpy of a reaction is defined as the system internal energy, that is E, plus product of the pressure and volume work, that is PV. Enthalpy at constant volume. First we have discussed enthalpy at constant pressure. Then it was equal to enthalpy and the sum of thermal energy and pressure volume work. Here the volume will be 0, change in volume will be 0, so the enthalpy will be equal to del E plus P del V. By putting the value of del V as 0, it means that change in enthalpy is only equal to the change in thermal energy, not on the pressure volume work. In case of volume constant, pressure will also be 0. But in case of pressure constant, it will be equal to pressure volume work and thermal energy. In case of volume constant, the pressure will also be 0 and change in enthalpy will equal to the change in thermal energy. Standard states and standard enthalpy changes. Del H varies with conditions, so standard values are used. Standard values are calculated when all the substances are in their standard states, means temperature, pressure, volume, energy, enthalpy. They all are in standard values, so we can calculate their standard states. The standard conditions. The standard conditions are 1 atmospheric pressure for gases, 1 atmospheric pressure and 25 degrees centigrade, that is optimum temperature for any element or compound in its stable physical state, 1 molar concentration for any aqueous solution. Thank you so much.